In section 3.4b, we are going to be working on linear programming, but this time it's going to be a contextual problem, which means it's going to be like a story problem. It's going to have a real-world scenario, and we are going to have to write our own system of constraints and our own objective function. And so we're going to use a table to help us get organized in that manner. Baking a tray of corn muffins takes 4 cups of milk and 3 cups of wheat flour. Baking a tray of bran muffins takes 2 cups of milk and 3 cups of wheat flour. A baker has 16 cups of milk and 15 cups of wheat flour. He makes $3 profit per tray of corn muffins and $2 per profit per tray of bran muffins. How many trays of each type of muffin should the baker make to maximize his profit? So we're kind of simplifying this down. Obviously there are other ingredients that go in muffins, but we are looking at a couple of limitations and the profit level so that we can create a system of constraints, find our feasible region, and then also figure out which combination of bran and corn muffins will earn the baker the highest amount of profit. So in reading through our information, we're going to organize that information in a table. Now they're already telling us in this problem that X is going to be the number of corn muffin trays that he makes and Y is going to be the number of bran muffin trays that he makes. So I'm going to go ahead and write that down because normally that's not going to be given. So I'll write X equals number of trays of corn muffins, Y equals number of trays of bran muffins. And we need to be very specific in saying that it's the number of trays of corn muffins. We can't just say X equals corn muffins because then we don't know what quantity we're talking about. We can't even say number of corn muffins because it's not individual corn muffins, it's trays full of corn muffins. So we have to be very specific in that. Now they have this organized by corn muffin column and then bran muffin column, and then each of the restrictions has its own row and the profit has its own row as well. So what I'm going to do is I'm going to kind of circle my information based on type. So I'm going to use blue here for the milk. So it tells me that corn muffins take 4 cups of milk and bran muffins take 2 cups of milk. So I'll put that in my information. Corn muffins take 4 cups of milk. Bran muffins take 2 cups of milk. Now that's per tray. So if I just leave a 4 in there, think about how many trays am I making? I'm only making 1 tray. If I was going to make 2 trays, then I would need to do 4 times 2, and that would be 8. If I was making 3 trays, it would be 4 times 3. But I don't know how many trays I'm making. I'm using X to represent how many trays of corn muffins I'm making. So in my box here, instead of just 4, which would be 1 tray, I'm going to do 4 times X, which will be X trays of corn muffins. Similarly for the bran muffins, I'm going to use 2Y for the number of trays of bran muffins. Now I have other information in here about milk. It tells me that the baker has 16 cups of milk. Now that's not 16 cups per tray, it's a total of 16. So that total is going to go 16 cups of milk. Now, we're going to do the same thing for flour. So with the flour information, for corn muffins it takes 3 cups of wheat flour, and bran muffins it takes 3 cups of wheat flour for a tray, and it tells us that the baker has 15 cups of wheat flour total. So for the flour, corn muffins take 3 cups per tray, so that will be 3 times X. Bran muffins also take 3 cups per tray, so 3 times y. And the baker has 15 total cups in inventory. The objective function, remember from when we started this section, we talked about the objective function is the thing we want to maximize or minimize. So this is what our objective function is going to be about. It's going to be about profit. So this right here is your objective function. So we need information about profit. It tells us that he makes $3 profit per tray of corn muffins, $2 profit per tray of bran muffins. So each tray of corn muffins is $3 profit, so that's going to be 3 for one tray, but 3 times 2 for 2 trays, and 3 times 3 for 3 trays, and eventually 3 times x for x trays. And then bran muffins will be $2 per tray, so 2 times y for bran muffins. And we're going to turn this table into our system of constraints. So I'm going to make myself that little squiggly mabobber thing. And the constraints are about the limitations. Constraints are the limited resources. It creates a system of inequalities. The objective function is what we want to maximize or minimize. In this case, we're maximizing profit. And if you remember from the previous lesson, this gets to be an equation. So all of our limited resources will go together to create a system of inequalities, but our objective function is going to create an equation. So it's almost always easier for me to do the objective function first, so that's what I'm going to do here. It's going to be an equation, and it's, in this case, we're trying to maximize profit, so it's going to be about profit. So when I write my objective function, it's usually going to be a word and then equals some combination of variables and numbers and operations that relate to that. So the word I'm going to use is profit. So I'm going to put profit equals, and then the profit I make from corn muffins is 3x, the profit I make from bran muffins is 2y, and I'm wanting my total profit, so I am going to add those together. So the objective function will be profit equals 3x plus 2y. And what I want to do with that is I want to maximize it. Now my constraints are going to be related to the limited resources. So in this case, the baker only has 16 cups of milk and 15 cups of flour to use in baking. Now with regard to the milk, he's going to use some for corn muffins and some for bran muffins, which means I'm going to need to add those together. And while he certainly can use all 16 cups, so I could put equals 16, he doesn't have to use all 16 cups, so I want to make it show that he could use up to 16 cups but no more than 16 cups. So I'm going to use less than or equal to. And that's going to be one of my systems of inequalities. So I'll have 4x plus 2y is less than or equal to 16. And then I'll do the same type of thing for the flour situation. He uses some for corn muffins and some for bran muffins, but he only has 15 cups total. So we'll have 3x plus 3y is less than or equal to 15. And that will go in my other system of inequalities. That will be my other inequality that goes in my system of constraints. And then you see that I've left some blanks there. there are some unwritten inequalities that we have to consider when we're creating our own system of constraints. And we talked about them in 3.4a, that it doesn't make sense since x represents the number of trays of corn muffins. X cannot be a negative number. The lowest number of trays of corn muffins that I could possibly make is 0. I make that much every day. So we would need to say that x needs to be greater than or equal to 0 because I can't make a negative number of trays. And same thing for the bran muffins, that y needs to be greater than or equal to 0. Remember, we talked about that these two together mean that I'm only graphing in the first quadrant. So that's why I've got my graph set up only to be that first quadrant where x and y are both positive. Our next step is going to be that we will graph the constraints on our hand-drawn first quadrant. I've already drawn mine, so you go ahead and draw yours, and then we'll need to graph this system of inequalities. Remember that we do that kind of by the cover-up method. So I cover up the y, I get 4x equals 16. So my ordered pair will be that x is 4, y is 0. And then I cover up the x, 2y equals 16. So that gives me 0 for x and 8 for y. So I'll graph those ordered pairs, 1, 2, 3, 4, 0, and 0, 8. And then I need to connect those with a solid line because that's a less than or equal to. And I need to test a point. So if I test 0, 0, which is down here, 4 times 0 is 0, 2 times 0 is 0, is less than or equal to 16. That is true. So I'll be shading down below that blue line. We'll do the same thing here for 3x plus 3y is less than or equal to 15. Cover up the y, 3x equals 15, gives me x is 5, y is 0. Cover up the x's, 3y equals 15, which gives me x is 0, y is 5. So I'll have 5, 0, and 0, 5. Connect those. Also with a solid line because of the inequality symbol. Go ahead and test the same point, 0, 0. So I'll have 3 times 0 is 0, 3 times 0 is 0, less than or equal to 15. That is true. So I'm shading below the green line as well. Remember that these two inequalities just mean I'm in the first quadrant, so there's nothing to graph. And then we shade only the overlap, so only where it would be below the green and the blue, which is going to be this little shape in here. Now, one thing that's going to be different about creating this graph versus when we don't have a story problem is that I'm not going to label my axis x and y. I'm going to label my axis by what x and y represent. So my x values were the number of trays of bran muffins. And my y-axis was the number of trays of, oops, I did that backwards. X was corn. My y-axis was the number of trays of bran muffins. Okay, we're good now. And I can go back in and label 1, 2, 3, 4, 5, 6, 7. I can label more of my tick marks. All right, the next thing after graphing our constraints and finding our feasible region, which is the shaded region, is to label the vertices of that feasible region. So, like we talked about before, when we didn't have a story problem, we just had regular inequalities. There are some that we can tell just by looking, and then there will be times that we have to solve a system of inequalities to find a vertex. So if I look on here, if I have vertex A, I'll label it A. This one is B. This one will be C. This one will be D. I can tell what A is. It is 0, 0. I can tell what B is. It is 0, 5. I cannot tell what C is. I'm going to have to figure that out. And I can tell what D is. It is 4, 0. So to find vertex C, I'm going to need to do some work to solve that system of equations. Remember that we change the inequalities to equations and then we solve for them using substitution or elimination. So my two equations will be the blue line, which was 4x plus 2y, we changed that to equals 16, and the green line, which was 3x plus 3y, changed that to equals 15. So that's two equations. I think I will choose to solve this by elimination. So I'm going to need to multiply one or both of my equations by some number so that the coefficients are opposite of each other. I think I will eliminate the y's. So I'll need to multiply equation 1 times 3. So that's going to give me 12x plus 6y equals 48. And then in order for my coefficients to be opposites, I'll need to multiply equation 2 times negative 2, which will give me negative 6x minus 6y equals negative 30. When I add those together, I get 6x, the y's cancel, and that equals 18, which gives me x equals 3. Then I can sub that in to either of my first two equations, either 1 or 2. I think I'll go with equation 1. So I'll have 4 times 3 plus 2y equals 16. So that's 12. So I'll subtract 12 on both sides. So 2y equals 4. Divide both sides by 2. So y equals 2. So my fourth vertex will be the ordered pair. X is 3. Y is 2. So the ordered pair, 3, 2. On the next step, I need to figure out what is the value of the objective function at each vertex. So remember, the objective function in this problem was about profit. It's that profit equals 3 times x plus 2 times y. So for each vertex, I will need to substitute in the x and y values and then work through them to figure out the profit. So for letter A, which was 0, 0, the profit will be 3 times 0 plus 2 times 0, which ends up being $0. For B, which was 0, 5, the profit will be 3 times x, so 3 times 0, plus 2 times y, which is 5. So that's going to be $10. C, which was 3, 2, profit will equal 3 times x, so 3 times 3, plus 2 times y, 2 times 2. So that is 9 plus 4, so $13. And then for my last one, 4, 0, the profit will be 3 times x, so 3 times 4, plus 2 times y, so 2 times 0, which ends up being $12. Now we have to check through only those 4 points. We don't have to check any more, even though any combination in here will work for my ingredients. So like, for example, I could make 2 trays of corn muffins and 1 tray of bran muffins, and by doing that, 2 trays of corn muffins would be 8 cups of milk, 1 tray of bran muffins would be 2 cups of milk, so that's 10, which is below my 16. Same thing for flour. I could do 3 times 2, which is 6, plus 3 times 1, which is 3, makes 9, which is below my 15. So there's lots and lots of combinations that would work, but the maximum and minimum are guaranteed to happen at one of these 4 vertices. So we only have to put in 4 possibilities. Then this question asks specifically at which vertex is the objective function maximized. So the objective function is its highest at 13, so that would be at the vertex 3, 2. However, we are going to write a statement based on this solution that does not just say 3, 2, and 13. It's going to be like a sentence that tells the baker what he should do and why he should do that. So it's like a little call to action with backing it up with what you found in your work. So we're going to say that the baker should make, the x value was the number of trays of corn muffins. So the baker should make 3 trays of corn muffins, and the y value was 2, so 2, and the y coordinates were the number of trays of bran muffins, so 2 trays of bran muffins. And why should he choose that particular combination? Because that's going to give him the maximum profit. So that's in order to earn the maximum profit. And we want to tell him how much that profit is going to be. So it's the maximum profit of $13. So make sure that you get all of that information when you state your answer in a complete sentence.